Okay, in order to understand trigonometry, we have to start off by understanding the language and terminology of trigonometry. So trigonometry essentially is the study of angles in a triangle and the relationship to the lengths of their sides. And I know that it seems very simplistic, but there's a lot to this. Trigonometry also deals with rotation and the angles associated with that as well. So in this first section or first lesson, we're going to be discussing the terminology of different types of angles and how angles are related to each other. So to start off here, we have a couple of angles. Now this angle on the left side here is considered to be in standard position. Standard position essentially means that the starting point is pointing towards the positive x-axis, okay? So if we were to think about this on a coordinate plane here on the x and y axis, then this angle over here is starting along the positive x-axis right here. And that's what we consider standard position. Now this initial side is where we begin the rotation of the angle. And then we end up rotating from 0 up and around to wherever we are. And this is what we consider a positive rotation, okay? And this right here is the terminal side of this angle. So you can see that it's kind of like a clock turning, except that it's turning counterclockwise. Now, if we were to look down here, this would, and on the right side, if an angle were starting in this position and coming down and around in a clockwise direction, this would be considered a negative rotation. Now you might notice this little symbol that's inside of the angle. And so we're describing this angle by the Greek letter theta. And we could call it any particular variable, but theta is a very common variable that we use for angles. And so this is really what we're going to be discussing first, all right? So in general, when we end up seeing a rotation curving up and around counterclockwise, this here would be a positive rotation, while going going clockwise, like on the right side, would be considered a negative rotation. Now we often refer to an angle of rotation, but oftentimes what we really mean is an angle measure. And so we have to come up with some sort of unit, some sort of method of being able to measure how big an angle actually is. And so the most common up until this point has been the degree measure. Okay. And so when we refer to 1 degree is actually just 1 out of 360 equal parts of a rotation. 1/360th of a rotation here, which seems like a really odd and arbitrary choice for breaking up a circle into 360 equal parts, where this piece right here, and that's even an exaggeration, okay, because that's even way bigger than 1 degree. But this right here, we can maybe say is 1 degree. It's a really tiny sliver of the whole rotation. So you might wonder, well, why 360? Why did somebody at some point in history decide to break this circle up into 360 equal parts? So there's a few different theories about it, but the main idea here is that it was developed by the Babylonians, who were brilliant people that came up with all kinds of developments in math and science. But one of these was breaking up a circle into 360 parts. And one reason why some think that this is actually the case is that, let's say that they walked out of their cave at some particular point in history, and they see a tree off in the distance. Okay, beautiful tree. And at some point they woke up right before sunrise and they see the sun rising straight over that tree. It's nice and beautiful. And they say, wow, I want to be able to see that every single day. Okay. And then they continue to wake up at different times throughout the year, and then weeks go by and they start realizing that all of a sudden it's not rising over that tree anymore. It's now rising over here. And they say, well, that's really odd. So they continue to watch it and it keeps moving along the horizon until one day it gets over to here, and then it starts to move its way back again. Over the months, it starts moving its way back. And it starts moving its way back, and sometimes it even passed over. But then it finally moved its way back over again until one day it ended up coming straight up and over that tree again. And if you ask yourself how long it took for that sun to come right over the top of that tree again, they started to take tally marks maybe on the inside of their cave. This is what I picture, right? And so they're looking at the tally marks over the years and they're thinking, man, there's got to be some sort of way for us to figure out how long it's going to take. And sure enough, by the time it ended up coming back over that tree, it was approximately 360 days. Now we know now that it was actually one full year, which is 365 and a quarter days or so. But it's really tough to tell the difference between where it was after 360 and where it was after 365. It might have just been just a little bit off. So what they recognized is that 360 was a great number for their society. They dealt with a sexagesimal system other than a decimal system, where it was a base 60 system. And the beauty of breaking 360 up is that it has a lot of different divisors. It could divide by 2, 3, 4, 5, 6, 8, 10, 12, 20, 24, 36, all kinds of different numbers. And so they loved the fact that, hey, what if we were to recognize that the Earth makes one full rotation around the sun in 360 days? Therefore, technically, 1 degree is equivalent to 1 day on Earth. And so that's why we've stuck with this degree measurement, meaning that 360 degrees is a full rotation. So 360 degrees equals 1 rotation. And then it starts over again. Okay, so now that we know that, that means that as we start to rotate up and around from 0 degrees, okay, that by the time we get to 1/4 of the circle, this is considered a 90-degree angle. We often put a square in the angle if it turns out to be a 90-degree angle. Otherwise, we just put a little arc, okay? If we look at half of a rotation, by the time we rotate around halfway, we've reached a 180-degree angle. If we continue to rotate around, each of these quadrants is going to be 90 degrees individually. So by the time we've rotated all the way around, even though this right here is technically 0 degrees, it turns out to be what we refer to as coterminal to 360 degrees. Coterminal means nothing more than it has the same terminal side. So let's take a look at an example of a couple of coterminal angles before we continue on. Now let's say that we have this angle right here, this angle theta. And maybe that angle it's a little over halfway into the quadrant. Halfway would be 45 degrees or half of 90. So let's just say that this is about 50 degrees, okay? So 50 degrees would be this angle, but notice that was starting at the angle of 0 and rotating up and around this way. Now, what if we were to look at a different angle that still ended at this exact same place? So perhaps we look at this angle right here that rotates all the way around to get to 360, and then it has to go 50 more. Well, a coterminal angle would be 50 plus an extra 360 degrees, which would give me an angle of 410 degrees. So therefore, 50 degrees is coterminal to 410 degrees. Likewise, we could do the same thing. What if we were to go 50 degrees? Maybe we get rid of this one. And what if we were to start at 50 degrees and now go down and around this way until we reach right back to here again? Notice that that's one full rotation off. So that means we could start with 50 degrees, and we could also subtract 360. Okay. And if we subtract 360, then that's going to give us a negative angle. It gives me negative 310 degrees. Which makes sense because negative 310 would mean let's start at 0 and go down and around almost one full rotation. So negative 310 degrees puts me to the exact same place as 50 degrees. So this is important because the information that we deal with in trigonometry are going to be very similar for coterminal angles. Now we could continue to take more and more rotations here. If we were to take more rotations, okay, let's see here. There we go. So if we were to take more rotations, then we could come up with another coterminal angle. Let's say that we started at 50 degrees and we rotated around one rotation to get to 410. And then we continued by taking a second rotation by going 360 degrees more. Well, that means we could start at 50 degrees and add 360 degrees twice, which means we're really adding 720 degrees, and therefore 770 degrees would also be considered coterminal to 50 degrees. Okay, so all of these are considered coterminal angles. So in general, coterminal angles look like whatever the angle is plus 360 degrees times n. So any value of n, any integer where n is an integer, any integer value of n will give me a coterminal angle to 50 degrees. So now that we know about degree measurement, we can come up with the names of a couple of special types of angles. So we already talked about this first angle, that's a 90-degree angle. We refer to this as a right angle. And a lot of trigonometry is based off of right triangle trigonometry. And so right angles occur when theta is equal to 90 degrees. Okay. And we also have another easy one over here because a rotation, half of a rotation of a circle is considered a straight angle. And straight angles occur when theta is equal to 180 degrees. You can see why we call it a straight angle, because it has a straight side, which means that the initial side is over here and the terminal side is over here, straight angle. Okay. So now we'd like to take a look at these other ones. So this situation here, where the angle is less than 90 degrees, but still greater than 0, is considered an acute angle, an acute angle. This is where theta is somewhere between 0 degrees and 90 degrees. It's a cute little angle, acute. And this angle over here, where the angle is greater than 90 degrees, is considered an obtuse angle. And so this is where theta is somewhere in between a right angle and a straight angle. So these are just a few different types of angles. So I'd like to now discuss what we mean by complementary and supplementary angles. Okay, now complementary angles and supplementary angles are any angles that add up to 90 degrees for complementary or 180 degrees for supplementary. So if two angles add up to 90 degrees, then those two angles, A and B, and let me be more precise with my notation here. It doesn't really make sense to say A plus B equals 90 degrees because A and B are just names of the angles. So what we often say when we're referring to the measure of that angle is that we say the measure of angle A plus the measure of angle B is equal to 90 degrees. And therefore A and B are considered complementary angles. Supplementary means that A and B, or the measures of A and B, would have to add up to be 180 degrees. And so if you already know one angle, then you could find its complement or its supplement by just subtracting from 180 to find what the result is. The next type of angle that I do want to mention, and I already mentioned it a bit earlier actually, but I never gave it a particular name, are called quadrantal angles. Now, when you look here at this positive x-axis as being 0 degrees, then anything that occurs in quadrant 1, here, is going to have an angle measurement that's between 0 degrees and 90 degrees. These are where all the acute angles live. Now, when you look over to quadrant 2, then all of the angles that live in this quadrant are going to be between 90 degrees and 180 degrees. So this is where all of the obtuse angles live. But notice that you could also have angles that extend down into quadrant 3 and into quadrant 4. And when you look at both of these quadrants, these are going to obviously be the angles that are between 180 degrees and 270 degrees. And this one down here will obviously be everything between 270 degrees and 360 degrees. And this is just referring obviously to the first rotation, because we could continue to rotate around and 410 degrees would lie somewhere in the first quadrant right here, okay? But each of the angles at the boundaries between quadrants are referred to as our quadrantal angles. Okay, so it's an angle. A quadrantal angle is nothing more than an angle that is not in a particular quadrant. It's actually on the boundary between two quadrants. So these are considered quadrantal angles. Okay, 90 degrees, 180 degrees, 270 degrees, and 0 degrees, and of course 360 degrees, and any coterminal angle to these angles. So these are all referred to as quadrantal angles. Now, the last thing we would like to discuss here is the relationship between, or rather how we could break angles up into smaller pieces. Because let's say that you were looking at an angle of 35 degrees, and then you looked at an angle of 36 degrees. Those obviously, if you think about it in terms of the day that we mentioned earlier, the angle that the Earth travels through in a day, there's a big difference between 35 degrees and 36 degrees. If you were to zoom in on that circle, you'd recognize that there's a lot of different angles in between. So we could give a decimal measurement and say it's approximately 35.23 degrees. But there's another convention that we use in trigonometry in order to break up circles into smaller, or break up angles into smaller parts. This is where we finally start getting into the math of trigonometry. So remember that really tiny sliver of an angle that we called 1 degree. Let's picture that as 1 hour, okay? We can break up an hour into smaller pieces called minutes. And we could break minutes up into smaller pieces called seconds. And so the Babylonian time ends up coming from the Babylonian sexagesimal system as well, because they've broken up every rotation into 60 minutes, or at every rotation of a second hand into 60 seconds. So we can basically see the same type of thing happening in angle measurements. The way that we describe this angle right down here is 51 degrees and 29 minutes. This angle is somewhere between 51 degrees and 52 degrees. So how do we end up describing this 29 minutes or this 46 minutes? So if we were to think about this symbol of a degree up here being an hour, then we could consider 1 minute, this little single apostrophe, 1 minute, as being 1/60th of a degree, which makes sense if you think about it in terms of time, because a minute is just 1/60th of an hour. So in other words, if we were to take 60 minutes total, I would end up getting a single degree. That tiny little sliver of a degree is made up of 60 minutes. Now, if we take a look over here, we could see that we could break up a minute into different seconds. So when we refer to a second, which we use with 2 little apostrophes here, then 1 second is going to be 1/60th of a minute, which makes sense, because if we were to think of it in terms of time, then 60 seconds would equal 1 minute. We could also think about it in terms of degrees, or 1/3600th of a degree, because if there are 60 minutes in an hour and 60 seconds in a minute, then there are 3,600 seconds in 1 hour. So for every 3,600 seconds, we've gotten to 1 degree. So again, you've got to visualize or try to picture that 1 degree as being that tiny little sliver, that 360th of a full rotation. And now we're breaking up that single little degree into tinier little pieces. So let's go ahead and take a look at these 2 examples here, where we're going to add and subtract some angle measurements that happen to have minutes involved. Okay. So if we were to add together 51 degrees and 29 minutes plus 32 degrees and 46 minutes, why don't we add those in a very similar way to where we would have done this with decimals, to where we can add up the degree measurements and we could add up the minute measurements. Okay. So this is going to give me 83 degrees total. And it's also going to give me 75 minutes. Now think about 75 minutes in terms of time. Okay, 75 minutes is more than an hour. So that means that this piece right here is going to be more than 1 degree. So we could think of 75 minutes as actually being 1 full degree, because that's 60 minutes, with 15 minutes left over. So if I were to add that to the 83 degrees that's already here, then that means that 51 degrees and 29 minutes plus 32 degrees and 46 minutes gives me a total of 84 degrees and 15 minutes. So minutes and seconds, they're nothing more than just portions of a degree. Let's do the same thing over here. So let's take 90 degrees and let's subtract 73 degrees and 12 minutes. Now you might notice that this is causing an issue in a very similar way to where if we ended up having 90 degrees and 0 minutes, we can't take the 0 minutes minus 12 minutes. So we have to do something a little different here. Why don't we go ahead and break up 90 degrees by taking one of those degrees away and making 90 degrees into 89 degrees plus 1 extra degree, which is 60 minutes. So 90 degrees is really an 89 degrees plus 60 extra minutes. So now if we think about it in that way, we could take 73 degrees and 12 minutes, and now we have something to subtract. Notice that by subtracting, this ends up giving me 16 degrees, while over here, we're left with 48 minutes. And so degrees and minutes are nothing more than just a way for us to, or degrees, minutes, and seconds are just a way for us to be able to break up degrees into smaller pieces instead of actually using decimals. Now, it doesn't mean we can't use decimals. So why don't we go ahead and take a look at another example where we want to convert degrees and minutes into decimal form. Okay, let's go ahead and start with that. Let's say we want to convert 74 degrees, 8 minutes, and 14 seconds into decimal form. Okay. So if we want to do this, then we just have to keep in mind how many minutes and seconds there are in a particular degree. So this answer is going to obviously be 74 point something degrees. So the first thing we can do here is just recognize, well, 74 degrees is already set up in the way that it should be. But what we want to do now is we want to add on how many degrees 8 minutes represents. 8 minutes represents 8/60ths of a degree. And likewise, if I wanted to convert 14 seconds, I've got to realize that 14 seconds accounts for 14 parts out of 3,600 degrees. And now if we were to convert each of those into a decimal, I'll let you do that on your calculator. Excuse me. This would turn out to be 74.137 degrees. And so essentially all we're doing is converting this into a fractional form of a degree based on how many seconds or minutes and seconds there are in a degree, and converting that into a decimal. Now going in the opposite direction is a little trickier, but let's try to now convert decimal degrees into degrees, minutes, and seconds. So think about what that 0.817 means. It's basically 34 degrees plus a portion of another degree. Okay, well, if we think about what that means, there are 60 minutes per degree. So this decimal is really just a portion of 60 minutes. So this is the same thing as 34 degrees plus 0.817 parts of 60 minutes. And so if you were to use your calculator, figure out what 0.817 times 60 is, that turns out to be 49.02 minutes. So I know that this is going to be equal to 34 degrees plus 49.02 minutes, 49.02 minutes. But notice that that really means the same thing as taking 34 degrees and 49 minutes plus another tiny little portion of minutes. And so we should be able to take that 0.02 and convert that into seconds by recognizing that this piece, okay, if 0.817 times 60 minutes was this amount, then we could rewrite 0.02 minutes as 0.02 times 60 seconds. Okay, so if there's 60 seconds per minute, then 0.02 parts of that minute is 0.02 times 60 minutes, or 60 seconds rather. So this still gives me my 34 degrees and 49 minutes. But we're now simply adding on 0.02 times 60. Okay. Let's scroll down a little bit more here so we've got a little more room. And so now we should realize that this extra amount, this 0.02 times 60 seconds, is 1.2 seconds. So we're now adding that 1.2 seconds to the 34 degrees and 49 minutes that I already have. But by the time we end up converting this into degrees, minutes, and seconds, we simply round that decimal right here because we don't use any decimals in degrees, minutes, and seconds. So my final result is 34 degrees, 49 minutes, and 49 minutes and 1 second. Okay, now we technically could say 1.2 seconds, but we typically just drop that decimal and that's our result. So just to see what we did here, we were able to convert from 34.817 degrees, which I know is somewhere between 34 and 35 degrees, into the form of degrees, minutes, and seconds. So different applications are going to be in different forms. Oftentimes degrees, minutes, and seconds are used in navigation, in stating what your bearing is when you are traveling by plane, by boat, and so on, while decimals are oftentimes the more standard measurement that we use in other applications.